happened. All right, what do you guys get?
X squared plus 12x plus 36.
Is that cool? Please, dear God, if you got x squared plus 36, leave that to yourself. You have to write this thing twice and then FOIL it out. Now, how's 12 related to 6? Twice. And why does it make sense? Because it's going to get 6, 6, going to get 2 of them. And so whatever this number is, the middle is always going to be double it. And the last term is always going to be that thing squared. So let's try another one just to make sure that's true. What about x minus 7 squared?
X squared.
So it'll be x squared minus 7x minus 7x
14x.
plus 49. So you get x squared minus 14x plus 49. Negative 14 is twice negative 7, and 49 is negative 7 squared. Of course, I mean, just think about it for a second. It's like, well, yeah, that shit's always going to happen, Jeff. So that tells me how to go backwards. If I know what's going to happen, if I know this number, I can relate it to this and this. Well, then tell me on this one. So that middle one is always going to be twice what was in here, right? Well, that middle one is always going to be twice what was in here. So if this has a 6x, right, what must have been here? 3. The middle guy. So what's the steps? It looks like the steps are middle guy divided by 2. To figure out, if I take the middle guy divided by 2, it's what was here. Take the middle guy divided by 2, is what was here. And then what goes here?
9.
Yeah. Square what you get from here. So this must have been a 9, and this will then be a 3. Okay. And you can see why this might be called completing the square. I figure out what I have to put here so that it factors as a square. Sean?
I'm misreading it. What does that say?
Where?
Does it say middle gay?
No, middle guy.
Okay, thank you.
Sure. And then square what you get. All right, that would be confusing. So down here, let's do a few of these together. So what I always do is I kind of do the 2 steps. What's the first step? What's the first step? Yes?
Is that from today?
It's from yesterday. Yeah. First step is always going to be cut the middle guy in half. So the first step would be 14 divided by 2 is 7. Now, we're just getting into this, right? But this process never changes. It's beautiful. If you cut the middle guy in half, that tells you what must have been here. There must have been a positive 7 there. And then if you take that number you just got and square it, 7 squared is 49. That must be what's there to make this work. So what I did was, if I add 49 to this side, I made it into something that could be written as something squared. I completed the square. Yeah. Say again?
If you're that much work, or can you just write 49 now?
Well, I'm going to show you, because I want to show you what the steps are. Right? But once you get the process down, you can pretty much do it in your head most of the time. You know the numbers are not always going to be that nice. And sometimes they won't be numbers. Aw, shit. All right. So like this one, here's the beauty of this process. No matter how ugly stuff gets, it's just a brute force. You just do it, right? So what's the first step?
5 divided by
Take the middle guy, divide it in half. So I get negative 5 over 2. And then your part of your brain goes, fractions, oh shit. But why do you not care? Because what do I do with the negative 5 halves?
X negative 5.
So you remember this, the first step, the beautiful thing about the first step is it tells you what's going to be in the answer. 7 must have been here. So where's the negative 5/2 go? Right there. So I already know what this is going to look like. All I have left to do is to figure out what to put here so that this actually works. And how do I figure out what goes here? Is I take this and I square it. What's negative 5/2 squared?
25 over 4.
25 over 4. So that's what goes here. Alright. There's one more, even slightly uglier looking one, but the funny thing is if you have a fraction and you're supposed to cut it in half, what's dividing by half? It's multiplying by, what's dividing by 2? It's multiplying by a half. So if I write, so if the first step is take the first guy and cut it in half, there. And what happens there?
Divide by 2.
So you get 1/3. Where's that 1/3 going to go?
1 over 9.
Positive 1/3 is going to go in here.
X.
And then how do I figure out what goes here? Yeah, take 1/3 and square it. So there must be a plus 1/9 there to make it work. Alright. Now real quick, I kind of like my worksheet a little better on this. This is the worksheet from that notebook thing I'm updating. Here's my little worksheet. So what I want you to do is look through these examples and then try the 2 out at the bottom there. This is showing you why completing the square is useful. And just to really make sure you understand the idea. Remember this problem we did? If I can write it like this, I can square root both sides. This one, I just had to factor it, and then I could square root both sides. This one, if I can figure out what to add here so that this becomes something squared, I could just square root both sides. So that's why this completing the square is useful. If I do this process, half of 4 is 2. That's what's going to go here. Half of 4 is 2. 2 squared is 4. That's what's got to go there. We should do one of those together. Here, let's do another one together. Let's see. Now right now, if I subtract 2, would I be able to factor that side? Subtract 2 over, would that factor? You guys see that that wouldn't factor. If I subtract 2, I get x squared minus 10x minus 2. I can't factor that. There's no factors of 2 that add to be 10. Not any nice ones anyway. So what I do instead is I do that completing the square. And normally the way I do it is right in the middle here I put a little. What's the first step? Cut the middle guy in half. Make it 5. And then take that number and square it. So this second step is what number I've got to put here. Now watch. If I have to add 25 here, I better do it the same. Do it to the other side, yeah. If I add 25 to this side, I better add 25 to that side. Now this is not difficult to factor, but the funny thing is, the part of this process has already factored it for me. How does this thing factor? Well, using that number. It factors like x minus 5 squared. And what do I get on the other side? 27. Now it looks just like this problem did. So now I can do the exact same thing I did to that problem. What do I do to both sides? Square root. x minus 5 equals plus or minus rad 27. What can I do with the 27? So x minus 5 equals plus or minus 3 rad 3. And the last step is add 5. So this is remarkably useful when you have an equation where if you get it equal to 0, I can't factor it. Yes?
Just how to get 27.
Say again? Because 2 plus 25. 27.
We actually got to the other side.
Yeah, didn't we? Was it there to begin with? So the original problem here was x squared plus, x squared minus 10x equals 2. That was the original problem. Then what did I do to this side? I added 25. So what do I have to do to the other side? Add 25. Okay, I like it. I like it. Yes, ma'am. Say again? This one here? Yes? Oh, because right here we can see that it's going to be like terms. I mean, to be honest, I could have done right here, I could have added 4. But I still have to do 4 plus 7, which is 11, and 4 minus 7, which is negative 3. Oh, what happened? See, on the one we just did, is 5 going to be like terms with 3 rad 3? Is it going to be like terms? No. So to get x by itself, I add 5 over and I'm done. If they're going to be like terms, I just need to get those terms together. Let's do another one. Okay, what about? Yeah. So really the idea, guys, the idea is to figure out what number do I add to both sides so that this side becomes something squared, because then I can just take a square root of both sides. That's the idea. So how do I figure out what number goes here? What's the 2 steps? Yeah, first step is cut 8 in half. And then the second step is square that. So where's the 16 go? Up here. If I put it there, I better put it there. And where's the 4 go? That's how this factors. Now, is this really hard to factor? No. But you will have situations where it would be very difficult to factor, and it's beautiful that the first step tells you how it's going to factor. Because that's a part of the process. That's a part of the pattern we saw. Yes?
So we can make that.
Yes. So continuing, just want to make sure everybody's with me so far. On this side, what do I have? 36. Now I take square root, plus or minus, x plus 4 equals plus or minus 6. So there's a few different ways I could do this. I know it's going to be like terms, I just need to get them together. I could either go ahead and subtract the 4 over, or I could say x plus 4 equals 6, x plus 4 equals negative 6. Mathematically, it would come out the same way. I'm going to subtract that 4 over eventually. So the way I've got it written, how do I do it? I do x equals negative 4 plus 6, or x equals negative 4 minus 6. So what do I get? 2? Negative 10. Now, anytime your answer comes out pretty, what that means is you could have factored the original problem. So let me just show you. But look, what was the original problem? Zoom out a little bit so you guys can see the whole thing. And again, you know, anytime you look at an entire math problem all at once, your brain kind of freaks out of it. But every step that leads to the next step is not as hard as the whole thing looks. Right? Okay. So what was the original problem? It was this. What if I subtract 20? What do I get? I get. Can you factor this? Yeah. How's a factor? 10 and 2. Careful. Bigger one's got to be positive. So you get x equals negative 10. X equals 2, which thank God is the same thing we just got the other one. Now look. Bless you. If I just said solve this, I would hope to God you guys would do this way. Because this way was a lot quicker than this way. Right? This process exists for those situations where you cannot factor. Will it still work if you could? Of course it'll still work. It's the more general way to do it. This is a more specific, easier way because I happen to be able to factor. If I make this 20 and 19, oh shit, I can't factor that worth anything. I'm going to do it this way. Holy crap. Do you guys? Now some problems are going to tell you, use this method, even though you could have factored it, just so you get used to how to do this step here. This like terms, how do you put those together? Are you guys, everybody semi with me? I get a feeling I might want to do another one. All right, there. Yeah, let's try one that's a little more disgusting. Ooh, I like it. Can you factor? Factors of 4 that add to be negative 14. No. So how is this problem different from the one I just gave a second ago? Remember the one I just gave a second ago looked like this to start with. This process needs room right here, right? So how do I make room there? What do I do with this stupid thing? Subtract. So make some room. Somebody else notice something nice here. In fact, every problem we've done so far had a what number in front of the x squared? Had what out there? 1. Completing the square is built on there being a 1 there. So does there have to be a 1 there? Yes, or else you can't do it. So what do I do now? Divide by 2. Don't factor this. Why would that not help you to factor that side? You could factor it all day long, but it equals negative 2. What's it supposed to equal so you can go further? 0. And it doesn't. So that's, you got to fight against your brain wanting to do that. It's not equal to 0. This is a different process. Even if that 2 was a 3, I would divide by it. I'd make a bunch of fractions. I'd cry a little bit, but too damn bad. The process needs a 1 here. So divide everything by 2. Now I've got plenty of room to work with. And here's the part, you guys, even as we do it, you're not going to believe me, but it's not as bad as it seems like it will be. What kind of sucks about that middle term? It's not even. Because what's the first step I got to do to figure out what to put here? Divide by 2. There's the first step, right? Take the middle term, coefficient, divide it by 2. And then what do I do with that? Square it. What do you get? 49 over 4. I love it. So where does this go? Goes right here. Look how pretty that is. If I put that there, I better put it there. This is the most common mistake, is to forget to do that to both sides. Now what's this tell me though? What's nice? Do you want to try to factor this? No. But what's nice is I don't have to think about factoring that at all because it's already done for me. This tells me it's going to be x minus 7/2. The first step you do is related to how that's going to factor. It does it for you. So the potentially really disgusting thing isn't because it's already done for me. That's awesome. The process does it for me. What do I get on the other side here? What do I have to do here? Yeah, it's fractions. So in order to add them, I have to get LCD. LCD. Say again. So LCD, not LSD, though. Some of the mathematicians probably were on. Is that, you guys with me? I mean, anytime you have fractions, too bad for you. You just got to do the right thing with fractions. So negative 4 plus 49.
45.
All right. Let me stop there for a second. Look at that beautiful thing. Thank you. So you always, whatever the middle term is, well, first you make room. We made room. Make sure that's a 1. We made sure that's a 1. Cut that middle guy in half. That's what goes in here. The next step is done for you in that first step. And then the second part of this is square what you just got, and that's what goes here. And, of course, there. Now what I do? Say again? Square root. So you got x minus 7/2, so I'll do that side. Equals, what goes in the bottom here? 2 on the bottom. 45 you can break up.
9.
Yeah, 45 is square root of 9, square root of 5.
So these.
All right, let me stop there for a second. See, and again, I keep saying this, but the people that are really good at math are the people that kind of naturally break things up into steps, break things up into parts, right? So every step I do is its own thing. I see square root of 45, that's reducible, that's one little thing, I can do that by itself. But then some people that not as good at math are the ones that just look at the whole thing like, I got to remember all this shit. No. There's a square root of 45, you can reduce it. You don't care about the other shit at that moment, right? Square root of 45 is square root of 9, square root of 5. Square root of 9 is 3. You get plus or minus 3 rad 5 over 2. Now look how gross that is. But think about it. Have I actually had to work much with fractions? The only thing I had to do with the fractions really directly was LCD. If you have trouble with that, you do not belong here. If you have trouble with that, you better stop. Or get some help. And then the beautiful thing is, the last step, it looks like, oh, it's so disgusting. Well, what's the only thing I got to do and be done? Add 7/2. And then I'm done. Done, because I got x by itself. And I could put these both over 2, but who cares? That doesn't really do anything for you. Huh? It actually makes it in the wrong form in a sense. Sort of like a plus bi. This is a plus b rad. So it's a little bit more. Who cares? Now, those of you that remember quadratic formula, this should look like the kind of answer you would get from quadratic formula. If you don't know quadratic formula, we're going to talk about it in a minute. Right now, I want you guys to try to do these two on your own. Try those two on your own. That's at the bottom of this sheet. Whoa. Huh?
You forgot my test.
Oh, gosh. I love it. There's just too much going on.
Can
All
you
right.
send it to them
Yes.
later?
Yeah, I got the email, but there's just too much happening. Yeah, okay. Oh, yeah. Mm-hmm. Okay, look at this first one. Did the first step up here, make some room. Now what are the two steps? Yeah, -6 divided by 2 is -3. Squared is 9. Where's the 9 go? And then this is going to factor as?
X square. 20.
Right. So that's the completing the square step. Because now I've put it in a form that I can attack directly. What do I do to both sides? 20, of course, is 4 times 5. Square root of 4 is 2. Square root of 5, I don't know. And then the last step, add that 3, and it just put it in front. Can you go any further? Uphill, right? You got 3 and 2 rad 5s. Can't put those together. Done. Number 2, are you guys done with that one? I'm going to sneak in a proof of quadratic formula before you get out of here. Sounds exciting. Got up this morning, like, man, I hope we do proof of quadratic formula. Shit. So what did I not do for you here? I didn't make some room for you, right? It's mean. So the first step, cut 7 in half. Second step, square it. That's here, 49 over 4. Where's that 49 over 4 go? Probably where I have my pen. Good. Good job, Mark. Somebody's got to keep me straight. And now how do you factor this ugly looking thing? Yeah. That tells you how to factor it. It'd be x positive 7 halves squared equals
69.
yeah. So multiply by 4. 20 plus 49, 69 over 4. All right, let me stop there for a second. So again, there's a lot of fractions in there, but the most I actually had to do with it was LCD. Right? It looks disgusting. It looks like, oh my God, how am I ever going to do this? But actually, most of the work is done for you in the process, in the two-step process. It's crazy. And then, of course, I square root plus or minus. Get x plus 7 over 2 equals square root of 69 over 2. 69 is 3 times 23. So I can't simplify it, right? And then I just do what to both sides? Yeah, subtract 7 halves. So I'm going to end up with negative 7 halves plus or minus square root of 69 over 2. Whoa! All right, so last thing for today. Fantabulous. The thing I just gave you has got room for this if you want to try to write this down with me. The quadratic formula. When I go senile, I'm going to walk around the town saying x equals negative b. This is the only thing left in my brain. Not there yet. So, oh, you're so excited. Because what am I going to do right now? I'm going to solve this. I'm going to solve this shit. This would be a lot of your worst nightmare because there's no numbers in your anywhere. So what do I have? You guys help me out though. You know the steps. What do I have to do first?
B divided by C.
It's nowhere near the right form to do anything with like that yet. What's in the wrong place? The C, I've got to get the C out of the way, right? Isn't that what we were doing earlier? So the first step is get that stupid C out of the way. Get out of there, C. And what else is not where it should be, or what else is wrong about this before I can start doing completing a square? There's an A, and there's supposed to be a 1. So I don't want to make A become 1. I divide it by A. Divide everything by A. Oh, man. Oh, focus. There we go. Everybody's like, I need help. No, fine. X squared plus B over AX equals, Jeff, you lost your space, you silly boy. X squared plus B over X. B over AX. I love it, Jeff. All right. Now, this is a perfect example of how the process does all the heavy lifting for you. There's very little lifting I've got to do myself. What's the first step to figure out what goes here? And here?
Divide by.
Yeah, take b over a divided by 2, which means multiply it by a half. So first step is b over a times 1/2 is b over 2a. The second step is take what I just got and square it. So I get b squared over 4a squared. So where's this going to go?
Right there.
I love it. I see where you're pointing, exactly. So right there and
Right there.
right there. So this is exactly the same steps we just did with a bunch of numbers in it. Doesn't matter, the math doesn't give a shit, it's a bunch of letters. What do I have to do on this side? How are you going to love this? How do you add those fractions? You have to have a common denominator. So this definitely needs a 4, and it also needs another a. That's trying to be a 4a up there. So I get, let me bring it up here. On this side, this becomes b squared minus 4ac, which should sound very familiar to some of you guys, all over 4a squared, which doesn't seem right yet. Whoops. That's what that is. That's what that is right there. B squared minus 4ac all over 4a squared. And on this side, how does it factor? How does this weird-ass thing factor with this? So again, it's, yes sir?
Isn't that top equation like a different equation for I forgot the unit.
Don't worry, we're creating what you're thinking about right now. All right. Now what do I do? Square root. Plus or minus, right? So we get x plus b over a. What's the square root of 4a squared? And the square root of b squared, I don't know. So we just leave that. Plus or minus out there. And then I just subtract b over a. Where did I lose? Oh, right here. This should be a 2a right there, guys. This here goes in here. Now if I subtract b over 2a, and combine these, I end up with the quadratic formula. That's where it comes from. So quadratic formula is a shortcut to completing the square. It's like before I know a, b, and c, I solved it. Now if I know a, b, and c, what can I do with those numbers? Throw them in. So real quick, for example, that last one we just did, what was the last one we just did? This one, x squared plus 7x equals 5. Okay, perfect. So if I subtract 5, I get this. What's a in this? What's a? 1. What's b? What's c? Beautiful. Now if you just plug all that stuff in there, bless you, -7, give or take, square root of 7 squared, minus 4 times a times c, all over twice a. See, a, b, and c just gets plugged in. And then you get -7 plus or minus 49 plus 20 is 69. And that, thankfully, where'd it go? It's the same thing we got. Bam, 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 bam. Okay. So quadratic formula is really just a shortcut to completing a square. That's all it is. All right. I'll see some of you guys in a few minutes in the lab.